Hello, I am Ramesh Shetty, Principal, Alva's PU College, Mudvidre. Today, I will discuss some questions on ray optics as a part of our online series classes. Let us start with the first question. A man is 180 centimeter tall and his eyes are 10 centimeter below the top of his head. In order to see his entire height, right from toe to head, he uses a plane mirror kept at a distance of 1 meter from him. The minimum length of the plane mirror required is. It's a basic simple question. Height of the mirror or size of the mirror is equal to half of the height of the observer. So that is, in this problem it is given man of 180 centimeter tall, therefore height of the observer is 180 centimeter divided by 2, it is nothing but 90 centimeter. That is option B. Dear students, I will explain with the diagram like this. This is the observer's eye, this is a mirror, this is the image of the observer. Therefore, you take two similar triangles, one is this and other one is this. Therefore, h by 2, height of the mirror, divided by h is this distance divided by this distance. Therefore, height of the mirror is half of the height of the observer. Once again, I will give some information about reflection through plane mirrors. For example, if two mirrors are placed at an angle theta, then number of images is equal to n is equal to 360 by theta minus 1. If 360 by theta is even integer, and 360 by theta, if 360 by theta is odd integer, then there are two possibilities like this, that is, two mirrors are placed at an angle theta and object is symmetrically placed, then n is equal to 360 by theta minus 1, like this. And if the object is placed asymmetrically, then n is equal to 360 by theta. For examples, if theta is 0, that is two mirrors are placed parallel to each other. For example, you can see in barber shop, if two plane mirrors are placed parallel to each other, then theta is 0, multiple images, number of images, infinite number of images. And other two examples like this, if theta is 180 degree, angle between two mirrors is 120 degree, this is the object, these two are the images, therefore two images. And angle between two mirrors is 90 degree, then this object 1, 2, 3. 3 images will get. Let us move on to question number 2. The focal length of a concave mirror is f and the distance from the object to the principal focus is x. The ratio of the size of the image to the size of the object is. See, in this problem it is given like this: concave mirror. It's a concave mirror like this. Focus, principal focus is f, and distance between the object, let us take object here, distance between the principal focus and the object is x, that is object distance u is equal to f plus x. Our aim is to find out the magnification. Magnification is equal to linear size of the image to the linear size of the object. Our aim is to find out this. Therefore, we have the formula hi by h naught is equal to image distance by object distance. For concave mirror, it is negative. Also, we have formula f minus v divided by f. Also, magnification is equal to f divided by f minus u. See, dear students, this is a shortcut method because it is given f and x, that is f and u. Therefore, m is equal to f divided by f minus u is the best formula to solve this problem. That's why here sign convention, using sign convention, f is negative, concave mirror, and u is also negative, it's equal to minus f plus x. it is negative. Substituting in this equation, m is equal to minus f divided by minus f minus of minus f plus x, like this. So for that is minus of minus plus, that is minus f divided by minus f plus f, and it is plus x. Therefore f cancel, is equal to minus f by x. Therefore answer is B. Dear students, once again recollect the sign convention. It is useful in the case of a mirror, also in the case of a lens. See this diagram. This is a pole. Always distances are measured from the pole and along the principal axis. Distances measured in the direction of the incident light is positive, and distances are measured in the opposite direction of the incident light is taken as negative. Heights or linear heights or distances above the principal axis is taken as positive. Linear heights below the principal axis is taken as negative. Same concept is used in lens also. Dear students, once again see the magnification formula. I compare with the mirrors and lens because sign convention is very important. For mirrors, m is hi by h naught is equal to minus v by u, f minus v by f, and f divided by f minus u. Whereas in the case of a lens, m is hi by v, here it is plus v by u, f minus v by f, same as mirror, but whereas in the case of a u and f, it is f divided by f plus u. Remember this and comparatively study this, you won't forget these formulas. Once again, see aerial magnification, it's also important formula. Some questions will be asked on this formula. This is for the case of a mirror. Aerial magnification using this 1 by v plus 1 by u is equal to 1 by f, mirror formula. Differentiating this, you can get this minus dv by v minus du by u is equal to 0, or dv by du is equal to minus v square by u square. This is for mirror. For the lens, it will be positive dv by du, that is aerial magnification is v square by u square. Okay, let us move on to question number 3. All of the following statements are correct except option A, the magnification produced by a convex mirror is always less than 1. B, a virtual erect same sized image can be obtained using a plane mirror. Option C, a virtual erect magnified image can be formed using a concave mirror. Option D, a real inverted same sized image can be formed using a convex mirror. In this problem, our aim is to find out the wrong answer, that is all statements are correct except. So here option is, it's D, is a direct question, but you should underline the word except so that you can answer it. The question option is D. One more some information about concave mirror, convex lens and concave lenses. For UV methods, very important graphs I will explain. See this, for concave mirror, this is the position of a pole. This graph is related to object is real and image is virtual. Whereas this graph, object is virtual, image is real. You see this, you are familiar to this graph, both object and image are real. This is a graph for concave mirror. See, for the convex mirror, both object is virtual and image is virtual in the first quadrant like this, and object real, image virtual, the second quadrant like this, and object virtual, image is real for the fourth quadrant like this for concave mirror. See the graph of lens, UV graph for convex lens and concave lenses. This is a graph for both object and image are real. This graph, see this is a pole. This graph for object virtual, image real, and this is a graph, this portion is for object real, image virtual. Similarly for concave lens, this is a graph of concave lens. Any question can be coined for CET or NEET examinations. We can go for fourth question. A fish is a little away below the surface of a lake. If the critical angle is 49 degree, then the fish could see things above the water surface within an angular range of theta, where theta is equal to, our aim is to find out the theta. See the diagram, the water level, fish underwater at a depth h, like this. So our aim is to find out this angle, whole angle theta. As you know, fish can see the outside world within a circle of radius r. That is, this is a critical condition, this is a critical angle. When this is critical angle, this angle is C. Therefore, this angle theta is equal to 2 times the critical angle, that is 2 into, it is given 49 degree, therefore it is 98 degree. Option C. Answer C. Okay, question number 5. A ray of light propagates from glass, refractive index 3/2, to water, refractive index 4/3, the value of critical angle. Light travels from glass to water. See this is a glass, this is water. Ray travels from glass to water. Ray goes like this, glass to water. Critical angle means angle in the denser medium, angle of incidence in the denser medium for with the refracted angle is 90 degree. Therefore, applying Snell's law at this point, refractive index of the glass into sin C is equal to refractive index of the water. Therefore, sin C is equal to NW by NG, that is 4/3 divided by NG is 3/2, nothing but sin C is equal to 8/9. Therefore, C is equal to sin inverse of 8/9. Therefore, answer C. Okay, question number 6. A ray of light is incident at 50 degree on the middle of one of the two mirrors arranged at an angle of 60 degree between them. The ray then touches the second mirror, get reflected back to the first mirror, making an angle of incidence of. See, the problem will be like this. Two mirrors are placed at an angle theta. Angle between the two mirrors is placed, it is 60 degree. Now, ray incident at an angle of 50 degree on one mirror like this. This is 50 degree. Okay, reflects. Naturally, this is 50. Once again, it incident on the second mirror. Angle of incidence and this mirror is, this is 50, here it is 40, 40 plus 60, 100. Naturally, this is 80, therefore this angle is 10. Reflects from the second mirror, goes like this. This is 10, angle of reflection is 10 plus 10, here it is 20. Our aim is to find out the angle of incidence in the first mirror, this theta. See, here it is 10, and this angle is 90 plus 50, 140, 140 plus 20, 160. Naturally, this angle is 20. Therefore, theta is equal to 90 minus 20 is equal to 70. Option C. Answer C. Let us move on to question number 7. The angle of a prism is 60 degree and its refractive index is √2. The angle of minimum deviation suffered by a ray of light in passing through it. Say the angle of the prism is 60 degree. It's a prism. Angle of the prism is 60 degree. Given A is 60 degree. Your aim is to find out angle of minimum deviation. Refractive index is given. It is √2. Therefore, using the formula, n is equal to sine of a plus d divided by 2 divided by sine a by 2. That is substituting √2 is equal to sine of 60 plus d divided by 2 divided by sine 60 by 2. Sine 60 by 2 is 30. Sine 30 is half. Bring it to here. √2 into 1 by 2 is equal to sine of 60 plus d divided by 2. That is, here it is 1 by √2. This side one is 1 by √2 sine of 60 plus d by 2. Therefore, 60 plus d by 2 is called sine inverse of 1 by √2 is 45 degree. That is 45 degree is equal to 60 plus d divided by 2. That is d is equal to 90 minus 60. I will write here. D is equal to 90 minus 60 is equal to 30 degree. Therefore, option B. Answer is B. Okay, we'll see next question. Question number 8. A telescope has an objective lens of focal length 200 centimeter and an eyepiece with focal length 2 centimeter. If this telescope is used to see a 50-meter tall building at a distance of 2 kilometers, what is the height of the image of the building followed by the objective lens? See, objective lens, here is eyepiece lens. This is the objective lens, here is eyepiece lens. Object, say 50 meter, this is the height of the object. It forms an image somewhere here almost at the principal focus of the objective lens. Because object distance is 2 kilometer, object distance is 2 kilometer, almost parallel ray incident on the lens forms an image at the principal focus of the objective lens. It's an approximation, almost approximation you can consider. Therefore, magnification is equal to height of the image by height of the object is nothing but image distance by object distance. Only for, I will consider only for the objective lens. Therefore, height of the image formed by the objective lens is V by U into H naught. Okay, U is given, its focal length is given, that is F naught, nothing but V. Therefore, substituting V is 2 meter divided by U is 2 kilometer, 2 into 10 to the power of 3 into H naught is 50 meter. That is 2 to cancel, 50 into 10 to the power of minus 3 or 5 into 10 to the power of minus 2 meter is nothing but 5 centimeter. Answer is A. Let us move to question number 9. A ray of light traveling in a transparent medium falls on a surface separating the medium from air to an angle of incidence of 45 degree. The ray undergoes total interreflection. If n is the refractive index of the medium with respect to air, select the possible values of n from the following. See this, ray travels from denser to the rarer medium. Let us take like this. The critical condition is this. If critical angle is 45 degree, then n is equal to 1 by sin c, 1 by sin 45 is equal to 1 by root 2, nothing but root 2. Root 2 is nothing but 1.414. If the angle of incidence is 45 degree, then rays suffer more. If the angle of incidence greater than the 45 degree, rays suffer total interreflection. That is, refractive index should be 1.414. In this option, there are 1.5 and 1.6 are the correct answers. Therefore, options or answers C and D both are correct. Let us move on to question number 10. A ray of light is incident at an angle I from denser to rarer medium. The reflected and refracted rays are mutually perpendicular. The angle of reflection and the angle of refraction are respectively R and R dash. Then the critical angle will be, see this, ray travels from denser to the rarer medium. Denser medium, this is a rarer medium. Incident angle is I, reflected angle is R, refracted angle is R dash. Angle between these two is 90 degree. Reflected ray and refracted ray perpendicular to each other. See, in this problem, you can use Snell's law or go for a shortcut method, that is, you can use Brewster's law. From polarization, you know Brewster's law. When ray travels from rarer to the denser medium, refractive index of the medium is equal to tangent of the polarizing angle. That is, here also very simple. Here ray travels from denser to the rarer medium. Take the reverse of it. That is 1 by n is equal to tan I. This is what shortcut method. Therefore, 1 by n is tan I. You know 1 by n is 1 by sin c. That's 1 by sin c goes to numerator. Therefore, sin c is equal to tan I. C is equal to sin inverse of tan I. Therefore, answer C. Okay, question number 11. A combination of two thin lenses with focal lengths f1 and f2 respectively forms an image of distant object at a distance 60 cm when lenses are in contact. The position of this image shifts by 30 cm towards the combination when two lenses are separated by 10 cm. The corresponding values of f1 and f2 are. Here, lens combination, two thin lenses are in contact. If two thin lenses are in contact, then the equivalent focal length is, reciprocal of equivalent focal length is equal to 1 by f1 plus 1 by f2, equation number 1. In the first sentence is given 1 by f is given 1 by 60 is equal to 1 by f1 plus 1 by f2. Okay, second sentence, if two lenses are separated by a certain distance and image shifts, this image distance, nothing but equivalent focal length distance is given 30 cm. Therefore, here the formula 1 by f dash is 1 by f1 plus 1 by f2 minus d divided by f1 f2. Substitute here 1 by 30 given 1 by f1 plus 1 by f2, you take this 1 by 60 minus d is given, also d is given, that is 10 cm. Here this distance 10 cm, that is 10 divided by f1 f2. Simplifying this, you bring it to this side. Therefore, f1 f2 10 divided by f1 f2 is 1 by 60 minus 1 by 30 is nothing but 60 common factor, that is 1 minus 2, it's minus 1 by 60. Therefore, F1 into F2 is minus 600. Product of focal length is minus 600. Substituting here, the 1 by F is 1 by F1 plus 1 by F2, that is F1, F2, F1 plus F2. Therefore, 1 by 60 is F1 plus F2 divided by F1, F2. Therefore, F1 plus F2 is product of this minus 600 divided by 60 is minus 10. See this, F1 plus F2, sum of the two focal lengths is minus 10, product of two focal lengths is minus 600. By infection you can say F1 is 20, F2 is minus 30. Sorry, answer B. Okay, let us move on to the next question. Question number 12. A ray of light falls on a transparent sphere with the center C as shown in the figure. The ray emerges from sphere parallel to line AB. The refractive index of sphere is, see the diagram, sphere, principal axis, here is the center C, and this is angle of incidence 60 degree. Say ray travels from rarer to the denser medium, moves towards the normal, it goes like this, then it refracts here, it is given this ray is parallel to the principal axis. Therefore, you draw a normal, it will be like this is a normal. Say this is the radius, this is the radius, these two are equal. Naturally, this angle is equal to refracted angle, this angle is also R. From the theorem, the exterior angle is equal to sum of the opposite interior angles. Therefore, this is 2R. Since these two are parallel, this should be 2R. These are geometry, simple geometry we can find out. This angle is 2R and this angle is 2R. Therefore, apply Snell's law at this point. N is equal to sin I by sin R. Nothing but sin 60, incident angle is 60, refracted angle is sin R. Equation number 1. Apply Snell's law at this point. That is, refractive index of this medium is N into sin of angle of incidence R, sin R, is equal to refractive index for RR medium is R. Okay, let us take NA or simply 1 into sin of angle of refraction, it is sin 2R. Here also N is equal to sin 2R divided by sin R, equation number 2. Therefore, from 1 and 2, N is N same, sin 60 by sin R is sin 2R by sin R, sin R cancel, nothing but sin 60 is equal to sin 2R. Therefore, 60 degree is equal to 2R, that is R is equal to 30 degree. Therefore, substitute here, N is equal to sin 60 divided by sin 30, that is root 3 by 2 divided by 1 by 2 is nothing but root 3. Answer C. Okay, question number 13. The ratio of thickness of plates of two transparent medium A and B is 6:4. If light takes equal time in passing through them, then refractive index of B with respect to A will be. See, light travels in two media. Distances S1, this is S2. Time taken by the light to travel these two media is same. You know time taken is distance by velocity. Therefore, T is S1 by V1, where V1 is the velocity of light in the first medium, and also equal to S2 by V2, where V2 is the velocity of light in the second medium. That is S1 by S2 is equal to V1 by V2. S1 by S2 is equal to, it is given 6 by 4. It's nothing but V1 by V2. You know, this is a medium A, this is a medium A, this is a medium B. Refractive index of the second medium, medium B, with respect to medium A is nothing but, by definition, it is the ratio of speed of light in the first medium to the speed of light in the second medium. Therefore, NB by NA is equal to 6 by 4. Answer B. Let us take next question. Question number 14. In the formation of a rainbow, light from the sun on water droplets undergoes. As you know, rainbow is due to the total interreflection and dispersion. Is a direct question. Answer C, dispersion and total internal reflection. Answer C. Okay, question number 15. Parallel beam of monochromatic light is incident at one surface of an equilateral prism. Angle of incidence is 55 degree and angle of emergence is 45 degree. The angle of minimum deviation will be, see this angle of incidence is 55 degree given, angle of emergence is given 46 degree. Our aim is to find out, you can find out delta, the angle of deviation is I plus C minus A, that is 55 degree plus C 46 degree minus 60 degree, nothing but it is 41 degree. See, delta, angle of deviation is 41 degree. Options, answers, that is less than or more than, equal to, like this. Therefore, you see the graph of angle of deviation versus angle of incidence. Graph will be like this. That is, this is a minimum angle of deviation. See, this is a minimum angle of deviation, delta M. This should be always less, D greater than dm. Therefore, D is always greater than delta M. Therefore, angle of minimum deviation delta M is less than or equal to 41 degree. Answer A. Okay, let us move on to the question number 16. A transparent cube of 15 centimeter edge contains a small air bubble. Its apparent depth when viewed through one face is 6 centimeter and when viewed through the opposite face is 4 centimeter. Then the refractive index of the material of the cube is. I will draw the cube, two-dimensional diagram of the cube like this. So let us take the air bubble is here. The real position of the air bubble from the first face is x. When this is viewed from this face, it appears to be come from this. This distance is the apparent depth. It is given 6 centimeter. When viewed from the second face, the air bubble appears to come from this position. This distance is given 4 centimeter. Therefore, you know, refractive index of the glass medium is n is equal to real depth by apparent depth. Here for the first phase it is x divided by 6 centimeter, and also for second phase refractive index is same. This is a real depth, this distance is real depth. This is 15 minus x, because this distance, total distance is 15 centimeter. That is 15 minus x divided by 4. Apparent depth is 4. Comparing these two equations, 6 by x by 6 is equal to 15 minus x by 4. Cross multiplying, 4x is 90 minus 6x. You bring it to this side, 10x is equal to 90. X is 9 centimeter. X is 9 centimeter. Substituting, n is 9 by 6. It is 1.5. Answer D. Let us go to question number 17. A plano-convex lens of refractor index 1.5 and radius of curvature 30 cm is silvered at the curved surface. Now this lens has been used to form the image of an object. At what distance from this lens an object be placed in order to have a real image of the size of the object? See the students, question number 17, plano-convex lens. It's a good problem. Plano-convex lens, refractor index is 1.5, radius of curvature is 30 centimeters given. Now this lens has been used to form the image of an object when the curved surface is silvered. See, when this curved surface is silvered, it's very important concept. You can silver the curved surface or you can silver the plane surface also. Number of problems can be coined on this concept. Here the curved surface is silvered. Now focal length is given. Focal length is, your aim is to find out, your focal length is, our aim is to find out. In this problem, say object, incident ray, let us take an object here, incident ray goes like this, travels in a lens, refraction takes place, then it reflects here, once again it comes, ray travels inside the lens and forms a final image. This is a rough diagram. Okay, that means equivalent focal length in this case is 1 by f1 for the lens plus mirror, right, reflect from the mirror, it's a concave mirror, 1 by fm plus when light comes back, once again a lens, 1 by f1. Therefore 1 by f is 2 divided by f1 plus 1 by fm. These are basic ideas in this problem. You can solve many problems on this for convex lens, also concave lens, and plano-convex lens and plano-concave lens also. Number of problems can be solved based on this. Idea is this: light goes inside the lens, behaves as a lens, reflects from mirror, behaves as a mirror, then when it comes back, once again behaves as a lens. Therefore 1 by f is 2 by f1 plus 1 by fm for this problem. You know lens maker's formula, 1 by f1 is n minus 1 into 1 by r1 minus 1 by r2. Here the plano-convex lens, one surface is, radius is infinity, this surface is radius r, therefore 1 by f1 is n minus 1 into 1 by r. Therefore 1 by capital F is 2 by f1, 2 into 1 by f1 is this, n minus 1 by r plus 1 by fm, 1 by fm is 1 by r by 2, it is nothing but 2 by r. 2 by r, 2 by r, 2 by r common factor, you take 2 by r into n minus 1 plus 1, that is 1 by f is 2n by r, or f is r by 2n. So this is what formula. Students should remember the formula, f is r by 2n. Shortcut method is f is r by 2n. Therefore r f is equal to r by 2n. R is given 30 centimeter, 2 into 1.5, it is 10. F is 10 centimeter. Our aim is to find out same size image formed as the same size of the object. That is, in the case of a lens, if object distance equal to 2f, then height of the image is equal to height of the object. Therefore, it is equal to 2 into 10. It is 20 centimeter. Option A. Answer A. Question number 18. A glass prism of refractance 1.5 is immersed in water. Refractance 4/3. Refer the diagram. A light beam incident normally on the face AB is totally reflected to reach the face BC if, see the diagram, the prism will be like this. It's in water. This angle is theta. Ray incident normally on this face. It's support TR like this. When this angle is theta, here 90, this is normal, therefore this is 90 minus theta, naturally this angle is theta. This angle is theta. Therefore, you know, critical condition, if it is a critical condition, C is equal to theta, ray suffer grazing emergence. Here it suffer total interflection, theta should be greater than C. Therefore, sin theta should be greater than 1 by n. N should be greater than 1 by sin theta. N is refractive index of glass, and here apply Snell's law at this point. Ng sin theta is equal to Nw. Therefore, sin theta should be greater or equal to Nw by Ng. Sin theta is greater or equal to 4/3 divided by 3/2. It's 8/9. That is sin theta greater or equal to 8/9. Answer C. Let us move on to question number 19. A convex lens of focal length f is placed somewhere in between an object and a screen. The distance between the object and the screen is x. If the numerical value of the magnification produced by the lens is m, then the focal length of the lens is. Question number 19. See, this is a object, this is a lens, this is a screen. Distance between the object and the screen is given, that is x. As you know, this is u, this is v, image distance. From this diagram you can see x is equal to u plus v, and you know by definition m is equal to v by u. Substituting, v is equal to mu, therefore x is equal to m u plus mu, that is 1 plus m into u x. Therefore, u is equal to x divided by m plus 1, that is 1. Equation number 1. Similarly, substitute for u, that is u is equal to v by m. Therefore, u plus v is x. Same equation. U is v by m plus v is equal to x. V into 1 by m plus 1 is equal to x. That is v is equal to mx divided by m plus 1. We get u and v. Our aim is to find out the focal length. F is equal to uv divided by u plus v for the lens. Therefore, u is minus, v is positive using sign convention, minus u is x divided by m plus 1 into v mx divided by m plus 1 divided by u plus v. U is minus x divided by m plus 1 plus v mx divided by m plus 1. Simplifying this, m plus 1, here m plus 1, this cancels, numerator remains x into mx divided by m plus 1, 1 m plus 1 remains, these two cancels, minus x plus mx, take it outside, x into m plus 1, and here minus cancels, x cancels, equal to x divided by mx divided by m plus 1 whole square. Therefore, answer A. Okay, dear students, let us move on to the question number 20. A concave mirror has a radius of curvature 40 centimeter. It is at the bottom of a glass that has water filled up to 5 centimeter. A small particle is floating on the surface of water. Its image as seen from directly above the glass at a distance d from the surface of water. The value of d is close to refractive index of water is given. Question number 20. See the diagram. It's a concave mirror. And it is filled with water like this. A floating object is here. This distance, object distance is given, u is equal to 5 centimeter. Concave mirror of radius of curvature 40 centimeter. Therefore, focal length is equal to 20 centimeter. You can find out the image distance. Okay. See, it's a concave mirror. Radius is negative. Center somewhere here. Focal length is negative. And object distance is negative using sign convention. Your aim is to find out image. Therefore, image distance 1 by f is 1 by u plus 1 by v. That is 1 by minus 20 is equal to 1 by u minus 5 plus 1 by v. 1 by v is equal to minus 1 by 20 plus 1 by 5, common factor 20. Here it is minus 1 plus 4, it is 3 by 20. Therefore, v is equal to 20 by 3 centimeter. That means somewhere here we'll get an image here. There's the image of the object floating body. This is the image distance from the concave mirror. We get positive value, means this is a pole. Distances are measured from the pole and along the principal axis. Incident the direction this. Therefore, it is positive. That is virtual image. V is equal to 20 by 3 centimeter. You are looking the floating object from this side. Therefore, this image appears to rise from somewhere here. This is a image observed by the observer. Our aim is to find out this distance. This distance is given as d. That is, refractive index is equal to total real depth by total apparent depth. Our aim is to find out the apparent depth is equal to total real depth by refractive index. Total real depth is, this is 5 centimeter is given. This image distance is 20 by 3 is given. Therefore, 5 plus 20 by 3 divided by refractive index is 1 by 3 is nothing but 1.33 is nothing but 4 by 3. For simplification, you can use like this. Therefore, this is 15 plus 20, 35 by 3. 3 cancel. 35 divided by 4 is nothing but 8.8 centimeter. Therefore, answer D. Okay, we can continue the next question. Question number 21. The ray diagram could be correct. A. If N1 equal to N2 equal to Ng. B. If N1 equal to N2 and N1 less than Ng. C. If N1 equal to N2 and N1 greater than Ng. D. Under no circumstances. See the diagram, question number 21. See the diagram. Lens is placed in another medium. Refractance of this medium is N1. Refractance of the glass is Ng. Refractance of this medium is N2. From the diagram, incident ray is parallel, refracted ray diverges. That means convex lens behaves as a diverging lens. Therefore, the refractance of surrounding medium is greater than the refractance of the glass. Therefore, N1 equal to N2 and N1 is greater than Ng. Here the answer is C. Correct option is C. Also, you can think in that way. If a concave lens immersed in a medium of higher refractive index, then this concave lens behaves as a convex lens. Okay, next question, question number 22. Convex lens of focal length 15 centimeter is made of a material of refractive index 3/2. When it is placed in a liquid, its focal length is increased by 0.22 meter. The refractive index of the liquid is, say, convex lens immersed in a liquid like this. In that case, focal length of the lens in a liquid is equal to NGL minus 1 into 1 by R1 minus 1 by R2. That is what lens maker's formula. Focal length of the lens increased, say focal length of the lens in glass is 15 centimeter or it is 0.15 meter, it is given. Focal length of the lens in liquid is FL is increased to 0.15 plus 0.225 is equal to 0.375 meter. FL is Ng by NL minus 1 by R1 minus 1 by R2 and 1 by F is Ng minus 1 by R1 minus 1 by R2 . From these two equations, FL by F is equal to Ng minus 1 divided by Ng by NL minus 1. That is 0.375 divided by 0.15 is equal to 0.5 divided by 1.5 divided by NL minus 1. It is 2 times 2.5, 2.5 is equal to 0.5 into NL divided by 1.5 minus NL. Solving, will get NL is equal to 5 by 4. Therefore, option B. Okay, let us move on to the question number 23. A point object is placed at a distance of 10 centimeter and its real image formed at a distance of 20 centimeter from a concave mirror. If the object is moved by 0.1 centimeter towards the mirror, the image will shift by about. Question number 23. Concave mirror like this given. object distance is equal to 10 centimeter using sign convention minus 10, and image distance is equal to 20 centimeter. It's also minus 20 using sign convention. You can find out the focal length. That is f is equal to uv divided by u plus v. That is f is equal to minus 10 into minus 20 divided by minus 10 minus 20. That is nothing but 200 divided by minus 30. That is minus 20 by 3. So you got the focal length. Therefore, minus 20 by 3 is the focal length of the lens. Our aim is to find out image object shifts by 0.1 centimeter. Now u dash is equal to 9.9 centimeter. Now v dash, your aim is to find out v dash. Therefore, 1 by f is equal to 1 by u plus 1 by v. 1 by f is minus 20 by 3 is equal to 1 by minus 9.9 plus 1 by v. If you calculate this, you will get v is equal to minus 20.4 centimeter. Therefore, initial image distance is 20 centimeter. Now minus 20.4 centimeter. Therefore, object or image moves 0.4 centimeter. Hence, answer A. Okay, you move on to question number 24. A point object is placed at a distance of 20 centimeter from a thin plano-convex lens of focal length 15 centimeter. The plane surface of the lens is now silvered. The image created by the system is at. Our aim is to find out the image distance. Plano-convex lens. Plane surface is silvered. Convex, this is a convex surface. Given object distance is 20 centimeter. Like this. Is the object. Object distance is 20 centimeter. Using sign convention, it is negative. And focal length is given 15 centimeter. Plane surface is silvered. Therefore, when the plane surface is silvered, it is a combination of lens and mirror. The equivalent focal length is equal to 2 by f plus 1 by fm. Plane surface, focal length of the plane surface is infinity. 1 by fm is 0. Then focal length of the equivalent combination is equal to f by 2. It is 15 by 2 is equal to 7.5 centimeter. Therefore, 1 by f is equal to 1 by u plus 1 by v. Focal length is 7.5. It is negative. 1 by minus 7.5 concave mirror is equal to 1 by minus 20 plus 1 by v. That is 1 by v is equal to minus 1 by 7.5 plus 1 by 20. It is minus 20 plus 7.5 divided by 20 into 7.5. That's 1 by v. 12.5 minus divided by 150. Therefore, v is equal to 150 divided by 12.5 minus, it is minus 12 centimeter. That is, object is image, we will get an image at 12 centimeter from the system towards the left. Therefore, answer C, 12 centimeter from the left of the system. Okay, dear students, I will give some information about the silvering of the lens. You take a lens, either a convex or concave lens. You can silver this surface. When light passes through the lens, say this, when ray goes, light travels in a lens. Once again it reflects from the mirror. Once again it comes back through the lens. Therefore, while light travels in a lens 2 times inside the lens, once reflected by a mirror. Same effect can be used for convex lens or concave lens or planar convex lens or planar concave lens. I will give some diagrams, you can understand more about this. For this planar convex lens, silvered at curved surfaces, it is nothing but 2 times lens and a concave mirror. Therefore, net formula will be 1 by f is equal to 2 by f1 plus 1 by fm. That is 1 by f is 1 by f1 plus 1 by fm for the mirror plus 1 by f1, where f1 is the focal length of the lens. That is nothing but 2 by f1 plus 1 by fm. This is a general formula. For this, fm r by 2, see this, fm is r by 2, f1 is lens maker's formula, 1 by f1 is equal to n minus 1 into 1 by r1 minus 1 by r2. 1 by r2 is plane surface infinity, 1 by r2 0. Therefore, f1 is r divided by n minus 1, n or mu, one and the same. Therefore, if you take these two, you will get f is r by 2 n for curved surface silvered. If plane surface is silvered, plane mirror 1 by focal length of the plane mirror is infinity, 1 by fm is 0, fm is infinity, 1 by fm is 0. Therefore, f is 2 by f1, that is nothing but r by 2 into n minus 1 only. See, for convex lens, equiconvex lens, silvered at one of the curved surfaces, it is nothing but 2 times lens and 1 times reflecting mirror, concave mirror. Therefore, net formula will be f1 is r by 2 n minus 1, fm is r by 2 curved surface spherical mirror. Net formula will be f is equal to r by 2 into 2n minus 1, or it is r divided by 4n minus 2 also. Okay, let us move on to the question number 25. A concave lens of glass refractor index 1.5 has both surfaces of same radius of curvature r. On immersion in a medium of refractor index 1.75, it will behave as. See, concave lens, question number 25. Concave lens immersed in a higher refractor index medium. Ng is this, NL is this. Ng is given 1.5, NL is 1.75. So, basic idea, when concave lens immersed in higher refractor index medium, it should behave as a converging lens. Therefore, convergent lens of focal length 3.5r or convergent lens of focal length 3r. So, option C and D you can ignore, only 2 options, or A and B. To solve this, 1 by FL is equal to NGL minus 1, 1 by R1 minus 1 by R2. That is what lens maker's formula. Both are converging lens. You take, this is a minus R, this is plus R, R1 is negative, R1 is negative, R2 is plus positive. Therefore, NGNL, NG by NL minus 1 into 1 by minus R minus 1 by R. That is, Ng is 1.5, NL is 1.75 divided by 1.75 into minus 2 by R. That is minus 0.25 divided by 1.75 into minus 2 by R, minus minus plus, that is 0.25 divided by 1.75, it is 7, 2 by 7 R, that is 1 by FL. Therefore, FL, focal length of the lens in liquid, is 7 by 2 R, is nothing but 3.5 R. See this, focal length becomes positive, that is nothing but a converging lens or a convex lens. Therefore, answer is A. Okay, let us go to the next question. Question number 26. A vessel of depth x is half filled with the oil of refractive index mu1 and other half is filled with the water of refractive index mu2. The apparent depth of the vessel when viewed from above is. Question number 26. Let us take a vessel like this, half filled. This is, let us take x by 2. This is x by 2 liquid and this is water. This is x. Okay, you know refractive index is equal to real depth by apparent depth. Therefore, total apparent depth is thickness of the one medium T1 divided by refractive index of the medium plus thickness of the second medium divided by refractive index of the second medium. Therefore, here T1 is x by 2 into n1 or mu1 plus T2 x by 2 into n2. X by 2 common factor 1 by n1 plus 1 by n2 or x by 2 into n1 n2 n1 plus n2. That is what total apparent depth. Therefore, answer is A. Question number 27. A fish looking up through the water sees the outside world contained in a circular horizon. If the refractive index of water is 4 by 3 and the fish is at 12 centimeter below the surface, the radius of this circle in centimeter is. It's a fish underwater problem. Water like this, fish at a depth of h meter. It can see the outside world within a circle of radius r. So this question number 27. So here the critical condition, the critical angle, this is C. Your aim is to find out the radius of the circle, this is R. R is equal to H tan C. This is one method. You can find out N is equal to 1 by sin C. You can find out C. Substituting, you can calculate R. The shortcut method is R is equal to H divided by root of N square minus 1. This is what shortcut method. Therefore, R is equal to H is 12 centimeter divided by root of 4 by 3 is N square minus 1. 4 by 3 square 16 divided by 9. 16 minus 9 it is 7. It is 12 divided by root of 7 divided by 9. Root of 9 is, remove it from square root, it is 3. 3 goes to numerator. Therefore, R is equal to 36 divided by root 7. Hence, answer is D. Let me go to the next question. Question number 28. A glass slab of thickness 3 cm and refractive index 3 by 2 is placed on ink mark on a piece of paper. For a person looking at the mark at a distance 5 cm above it, the distance of mark will appear to be. Question number 28. Glass slab, thickness is 3 cm, a ink dot on a paper. You observe this from this side. This is actually a 5 centimeter. The real depth is 5 centimeter. It appears to be from here, somewhere here. That is, object in the denser medium, normal shift takes place. You know refractive index is equal to real depth by apparent depth. So this is a real depth. This is a apparent depth. Here it is very simple problem. Real depth is 3. Refractive index is given 1.5 is nothing but 3 by 2. Therefore, real depth is 3, apparent depth is 2, nothing but this is 2 centimeter. Total distance is 5 centimeter. From here to here, it is the apparent distance is nothing but 5 minus this is normal shift is 1 centimeter, it is 4 centimeter. Therefore, answer is B. Let me move to question number 29. A plano-convex lens fits exactly into a plano-concave lens. Their plane surfaces are parallel to each other. If the lens are made of different materials of refractive indices mu1 and mu2 and r is the radius of curvature of the curved surface of the lenses, then the focal length of combination is. Question number 29. A plano-convex lens exactly fits with the plano-concave lens. Plane surfaces are parallel. Radius say same. Radius is r and r. Refractive index is n1 and n2. Say n1 nothing but refractive index. Also it is denoted as mu. Okay, mu1 or n1, one and the same. Let me write n1 only. This plano-convex lens and plano-concave lens, combined lens, that's the equivalent. Focal length of the equivalent lens is 1 by f1 plus 1 by f2. Whereas 1 by f1 is plano-convex lens, 1 by f1 is n minus 1, 1 by r1 minus 1 by r2. I will not write because 1 by r2 plane surface infinity, 1 by r2 is 0. Therefore, n minus 1 by r1. Convex lens, focal length is positive. 1 by f2 is n2 minus 1, 1 by r2. That is r2 and r1 is same here. R same. Therefore, you can write r1. Therefore, 1 by f1 is n1 minus 1 by r plus 1 by f2 n2 minus 1 by r. R2 is nothing but r and it is negative because a concave lens. Simplifying this, 1 by r common factor n1 minus 1 minus n2 minus of minus plus 1. 1 cancels, nothing but n1 minus n2 divided by r, that is 1 by f. Therefore, f is equal to r divided by n1 minus n2. F is r divided by n1 minus n2. Therefore, answer is option D. Okay, we'll go to the question number 30. The image of an electric bulb fixed in a wall is to be obtained on the wall opposite to it at a distance of 3 meters. The maximum possible focal length of the convex lens is. Question number 30. Okay, here the bulb and here the wall. This distance is 3 meters is given. A lens is here. Your aim is to find out the focal length of the lens. It's as you know, the shift method, distance between the object and the screen for a real image of a lens is D should be greater than or equal to 4f. This is a minimum condition. Therefore, minimum distance is D is equal to 4f. D is 3 meters divided by 4 is equal to f. That is, f is equal to 0.75 meter. Answer is C. Let me go to the question number 31. A point object is placed at a distance of 12 cm on the axis of a convex lens of focal length 10 cm. On the other side of the lens, a convex mirror is placed at a distance of 10 cm from the lens such that the image formed by the combination coincides with the object itself. What is the focal length of the convex lens? See this, convex lens, focal length is given, its focal length is 10 centimeter and at a distance of 10 centimeter, a convex mirror is placed, its focal length, your aim is to find out. Object is placed 12 centimeter from the lens. Refraction through the lens, it forms an image Your aim is to find out the image distance, and when light incident on the mirror retraces its path and forms the image side by side of the object. That is, ray diagram will be like this. It goes like this. It goes like this. Retraces the ray. That means the ray incident on the mirror should be normal. When ray incident normally on the mirror, it should pass through the center of the curvature. So retraces, final image forms at the object itself. This distance should be r. That is, this distance should be v. Therefore, v is equal to, your aim is to find out v so that you can find out r, then you can find out the focal length. 1 by f for lens is 1 by f1 is 1 by v minus 1 by u. 1 by 10 positive, 1 by v minus 1 by minus 12. Therefore, 1 by 10 equal to 1 by v plus 1 by 12. 1 by v is equal to 1 by 10 minus 1 by 12. Common factor 60. Here 6 minus 5, it is 1. That is, v is equal to 60 centimeter. Therefore, r is equal to 60 minus 10. It is 50 centimeter. Radius of this convex mirror is 50 centimeter. You know, focal length is equal to r by 2. It is 25 centimeter. Hence, option A is the correct answer. Answer A. Next question. Question number 32. A prism of certain angle deviates the red and blue rays by 8 degree and 12 degree respectively. Another prism of the same angle deviates the red and blue rays by 10 degree and 14 degree respectively. The prisms are small angled and made of different materials. The dispersive powers of the materials of the prisms are in the ratio. Question number 32. Your aim is to find out the ratio of dispersive powers. You know, dispersive power omega is equal to difference in the ratio of difference in the deviation to the mean deviation. Therefore, omega 1 by omega 2 is equal to d1 minus d2 divided by d divided by d1 dash minus d2 dash by d dash. Here 8 and 12, that is 4 divided by 10. Then here 10 and 14, that is difference is 4 divided by 12. Nothing but 12 by 10, that is equal to omega 1 by omega 2 is equal to 6 by 5. Answer is C. Let me go to the question number 33. A double convex lens has focal length 25 centimeter. The radius of curvature of one of the surface is double of the other. Find the radii if the refractive index of the material of the lens is 1.5. Question number 33. Given f is 25 centimeter, n is 1.5. Let me take r1 is equal to r and r2 is equal to double 2r. Your aim is to find out r1 and r2. This is how much? Okay, r1 r2, your aim is to find out. Using lens maker formula, 1 by f is n minus 1, 1 by r1 minus 1 by r2. 1 by 25 is 1.5 minus 1. 1 by r1 is r, minus 1 by r2 is negative, that is minus 2r, like this. That is 0.5 into 1 by r plus 1 by 2r, that is 0.5 into common factor 2r, 2 plus 1, 3 divided by 2r, 1 by 25. Therefore, r is equal to 0.5 into 3 into 25 divided by 2. 25 into 3, 75. 75 into 0.5, 37.5 divided by 2, 18.75. That is, R1 is 18.75, R2 is equal to 2R, it is 37.5. Therefore, answer is C. Okay, we can go to the next question. Question number 34. The light ray is incident at an angle of 60 degree on a prism of angle 45 degree. When the light ray falls on the other surface at 90 degree, the refractive index of the material of the prism mu and the angle of deviation delta are given by. It is given prism of angle 45 degree. Angle of the prism is given. Incident angle is given 60 degree. I is given 60 degree and refracts it incident at 90 degree normal to the other surface like this. Now your aim is to find out refractive index n or mu. Okay, one and the same is how much and deviation angle delta is how much. Our aim is to find out n and delta. From Snell's law, here see this diagram, here 90 degree, this is 45 degree, naturally this angle is 45 degree, therefore this is a normal angle of refraction from the diagram. R is equal to 45 degree. N is equal to sin I by sin R, that is sin 60 divided by sin 45, that is sin 60 is root 3 by 2 divided by sin 45, 1 by root 2 is nothing but root 3 by 2 root 2 by 1, nothing but root of 3 by 2. N is root of 3 by 2. D is deviated angle. You know delta is equal to I plus C minus A. I is 60 degree and emergent angle normal incidence, therefore 0, minus A is 45 degree, it is 15 degree. Therefore N is root 3 by 2 and delta is 15 degree. Answer is C. Okay, let me go for the next question. 35. The graph between the lateral magnification M produced by a lens and distance of the image V is given by. Question number 35. You know magnification is equal to linear size of the image to the linear size of the object. Nothing but Hi by H naught, nothing but V by U also equal to F minus V by F. That is M is F minus V by F, that is 1 minus V by F, or M is, you can write like this, minus F minus V by F plus 1. It is nothing but Y is equal to Mx plus C. Compare these two equations. It is the equation of a straight line. So X is your M and V are variable, Y and X are variable. M is minus 1 by F, minus 1 by F. Therefore, it is a negative slope. M and V variables. From the graph, M versus V is negative slope. Option C is a correct answer. Answer C is a correct answer. Okay, next question. Question number 36. A lens of focal length power 0.5 diopter is. Focal length 0.5 given. 36. Question number. Power is 0.5 diopter. It is positive. Naturally, it is a convex lens or converging lens. To find focal length, F is equal to 1 by P. That is 1 by 0.5. Therefore, F is equal to 2. Converging lens of focal length 2 meter. Converging lens, convex lens of focal length 2 meter is the correct answer. Therefore, answer is C. Let me go to the next question. Question number 37. An equiconvex lens is cut into two halves along one XO X dash and second YO Y dash as shown. Let F dash and F double dash be the focal lengths of a complete lens of each half in case 1 and of each half in case 2 respectively. Choose the correct statement from the following. Say this is a lens given like this. Question number 37. This is XOX dash. This is YOY dash. Focal length of the lens is given F, and if you cut the lens along x-axis like this, its focal length is F dash, its focal length is F dash is given, and if you cut the lens along y direction like this, then its focal length is F double dash is given. You know lens maker's formula 1 by F is n minus 1 into 1 by R1 minus 1 by R2. Suppose a parallel ray incident on the lens like this, it will focus at the principal focus. This is nothing but focal length. Therefore, this lens and this lens, parallel rays incident on this lens also, this portion of the lens, no change in the focal length, that is F1 is equal to F dash. This is first part. When you cut the lens like this along y direction, it's a combination of two lenses, two planar convex lenses like this, one and another lens. Each part focal length F dash. Therefore, 1 by F is 1 by F dash plus 1 by F dash, combination of two lenses. Therefore, F dash 2 by F dash. Therefore, F dash double dash, F double dash is equal to 2F. Therefore, F is equal to F dash and F double dash is equal to 2F. Therefore, answer is D. Let me go to the next question. Question number 38. Two objects A and B, when placed in turns in front of a concave mirror, give images of equal size. The focal length of the concave mirror is 7.5 centimeter and the size of object A is 3 times the size of the object B. The distance of B from the mirror, if A is placed 30 centimeter from the mirror, is. This problem, it's a concave mirror is given. Focal length of the mirror is given 7.5 centimeter. Image produced by the object A and object B is same, H1 equal to H2. You know magnification produced by the object A is, let me take MA, is H1 divided by HA. Magnification produced by the object B is MB is H2 divided by HB. Take the ratio of this, MA by MB is equal to H1 equal to H2, that is H1 by HA divided by H2 by HA. Divide these two, nothing but HB by HA. Problem given like this, height of the object A is 3 times the height of the object B. Therefore, HB divided by 3HB is nothing but 1 by 3. MA by MB ratio of magnification is 1 by 3. You know, say magnification MA is in terms of focal length and object distance, F divided by F minus U A, and MB is equal to F divided by F minus UB. Therefore, taking the ratio 1 by 3 is FF cancel, MA by MB 1 by 3, FF cancel. Therefore, F minus UB divided by F minus UA, using sign convention, minus 7.5 minus UB. I don't know whether it's positive or negative, and this is minus 7.5 minus UA, minus of minus, it is given 30. Object distance from the mirror is 30 for A is given. Therefore, 1 by 3 is equal to minus 7.5 minus UB divided by minus 7.5 plus 30. Simplifying, minus 7.5 plus 30 is equal to 3 into 7.5, that is 22.5, that is minus 3 UB. You bring it to, this is 22 point minus plus 22.5, you bring it to this side, plus 22.5, that is nothing but 45 is equal to minus 3 UB, that is UB is equal to minus 15. Minus sign indicates object is here, naturally negative sign convention it comes, negative minus sign, the object distance is 15 centimeter, therefore answer 15 centimeter from the mirror, it is answer is B. Okay, let me move on to the next question, question number 39. A compound microscope has an eyepiece of focal length 10 centimeter and an objective focal length of 4 centimeter. Calculate the magnification. If an object is kept at a distance of 5 centimeter from the objective, so that the final image is formed at the least distance of distinct vision, 20 centimeter. Is a compound microscope, formula is M is V naught by U naught into 1 plus D by Fe. For compound microscope, V naught is the image distance of the objective lens, U naught is the object distance of the objective lens, D is LDDV, F is the focal length of the eyepiece lens. For objective lens, 1 by F naught is equal to 1 by V naught minus 1 by U naught. It is given 1 by objective focal length is 4 centimeter. Convex lens positive is equal to 1 by V naught, your aim is to find out, minus 1 by minus its object distance is 5 centimeter. Sign convention using it is minus. Therefore, it minus or minus plus. 1 by V naught is 1 by 4 minus 1 by 5. Common factor 20. Here it is 5 minus 4. It's 1. Therefore, V naught is equal to 20 centimeter. V naught 20. Substituting for magnification, M is V naught 20 divided by U naught is 5 minus 5. Okay. Then 1 plus D 20 is given by Fe is given 10. 1 plus 2 3, 60 by 5 it is 12. Therefore, answer is A. Okay, let me take the last question of this session. Question number 40. A watch shows time as 3 hours 25 minutes. When seen through the mirror, the time appeared will be. So, very simple question. You subtract from 12 hours, that is 12 hours minus 3 hours 25 minutes, like this. So, 12 hours means 11 hours 60 minutes, you take like this, minus 3 hours 25 minutes. Nothing but this is 35 minutes and this is 8 hours. So, in the case of a mirror, you can see the time as 8 hours 35 minutes. Option A. Answer is A. Hello students. I wish you good luck for coming examinations, maybe English, CET, JEE or NEET. I hope you and your family members are safe at your home. Due to this coronavirus, the whole world is facing a problem. Because of this, we started online coaching for the benefit of our students. I request you to utilize it and work hard for coming examinations. Once again, I wish you good luck. Have a bright future. Thank you.